lots of data. Percentages deal with like part to whole. So if we have a fraction like 4 out of 10, and somebody earns that on a test, for example, like 4 correct out of 10. 4 is their part, 10 is their whole, and that's going to be something like 40%. And so when like Natalie says something in a meeting, like 40th percentile is considered benchmark, or students who score 40 in the 40th percentile on the STAR, that's different than saying they got 4 out of 10 correct, or that they got 40% correct. What that's saying, when we talk about percentiles, we're saying that we've looked at data, and actually a tremendous amount of data. Millions and millions of kids are taking the STAR test across the country. And so what that allows us to do then is compare that data, and then it spits out what's called a bell curve. And this is an overly simplified example, but it's just kind of easy to see. Every single data set spits out a bell curve if you have enough entries, and I think it's only like 31 plus 1, a number 30 plus 1 that you need. So even if you did like Hedges or even a grade level, it's going to spit out a bell curve that kind of norms the data compared to other people. This way you can see where people fall in that data. Right in the middle is considered the mean, and that's where half of the people half of the people scored above the average, half of the people scored below the average, roughly. Within that, about here, okay, is one standard deviation from the mean. 68% of people, so roughly 2/3, are going to fall within this area here. So if they're falling within this area, they are scoring very well. They're within one standard deviation of the mean. So if they are, here would be the mean, so like 34% and 34%. So the reason that the district decided to do a benchmark of 40% was because if they're scoring in here, that we don't want to give them intervention that they don't need. Okay, so if they're scoring out here, this gets into like the 99th percentile. Score within this entire, so like all of this included, is like the 3rd standard deviation out here. And so those are your kids that are scoring like in that 99th percentile. In the entire country, they're scoring in here. And then you have your students who are scoring like in the bottom 10 percentile, they're down in here. Okay, and so those are the students that need the intervention because they scored within, if I say the 10th percentile, what I mean is that out of 100 kids who take the test, they scored at or better than only 10 of them. And then you start to kind of look at, 1 million people, like if you start adding zeros here, then 10,000 kids took it, they scored better than 1,000. And if you just keep, adding zeros here, they scored better than 10,000. So these kids here are your urgent intervention down here. Then you've got your strategic intervention here, and then anything above that 40th percentile is fine. And that's like for the fall. Okay. Then if we take it again in the winter, one thing to understand is that everybody did. Okay, so this is going to move. And so when you talk about like moving benchmarks and things like that, it gets fuzzy because it's really hard to say, well, we're going to take a look at their fall data and then put them somewhere in here. Let's just say they scored at the 50th percentile, right on the average. That means then when we take it again in the winter, they could have improved their score but still fallen within the 50th percentile. Because everybody moved. And so that's kind of one of the challenges that we at Hedges kind of feel is like, well, what is considered appropriate growth or what is considered reasonable growth? And that's, when you look at percentiles, that's very, very difficult to do because you're not comparing really the same things. And so if you take it like here, we get another bell curve average here in the winter. okay, and they scored at the 50th percentile in the fall. Even if they score in the 45th percentile, like we went way down. Not really. They could have actually increased their scores, but gone down in percentile-wise, which isn't even necessarily a bad thing. What we want to know, and the STAR scores will tell us this, what we want to know is like what is considered adequate growth for that particular student. And that's why we need a lot of data points to do that. So one of the reasons why, you know, Danny has been pushing for lots of data points is because all of that data, and this might start getting a little bit more confusing, but let's just say one of their scores was here, and we've all seen those printouts, right? Where they get a square, and then they take it again, and they get another square, and they take it again, and they get another square. The reason that we're doing that is because they're trying to find that best fit line based on the residual values between this difference, and that difference. And what you want them to be is roughly the same above and below. So you want roughly like the same above and the same below. And so as teachers, we kind of fall into this trap that, oh my goodness, like they went from here, you know, at this level, and then they went way down here. Well, they may have gone down, but if you consider that the entire country took that test and maybe improved, then they not necessarily haven't gone down, they just haven't increased at the same rate that maybe their peers have. And so it's kind of that theory of marginality, like in economics, that it can increase at a diminishing rate. So something can, you know, increase over time, but yet at some point, right, you're going to eventually, you know, I'm increasing, yay, I'm making really good gains, but then I start to do that. And that's what we find with high kids especially. And it's really, like, we can make huge gains with kids who are urgent intervention, but then at some point here, like when you're seeing kids in the 80th percentile and up, that's extraordinary that they're scoring at that level. You can't expect to even improve at all. I mean, you can improve, but you can't expect it to improve because the math just doesn't work that way. It's not a linear function. And so if we have a linear function, like let's just say speed and distance traveled. Like if this is a 1 hour, right, and I'm stopped, I'm going to go 0, right? If I travel for an hour at 60 miles an hour, I'm going to go, you know, 1 mile or whatever. And so speed is a very linear function you can measure. But when we have these kids take the STAR test, it's not linear at all. Okay, it looks like this. It looks like that. Okay, so I don't know if I'm making it clear enough to be completely understood, but I guess if there's one takeaway from this, it's that the 40th percentile means that they're scoring better than 40%, or basically they're scoring at or better than 40% of their peers, which is totally fine. There's nothing wrong with that. And then the other takeaway, I guess if there were two, is that when you compare data over like 2 different benchmark areas, you're not really even comparing the same things, because you can by the kid, but you cannot compare that kid to everyone else. It's even grade level wise. And one thing to know too is that a lot of teachers will say, well, my kid is testing at the 5th grade level or the 6th grade level or whatever. That isn't necessarily true. Like we, especially when I taught 5th grade, I would see that and I'd be like, oh, these kids are testing at 8th grade plus. That does not mean that they can go into an 8th grade class and be successful. What that means is that they are scoring at roughly the same standardized score that an 8th grader in that month would maybe score. But that 8th grader is going to be one of these, right here. Does that make sense too? Like, and I don't mean to use like 8th grade, but even if I'm a 3rd grade teacher looking at 5th grade, one of my kids tested at the 5th grade level, yay, right? That's awesome, yeah, wonderful. But that just means that they tested about what this 5th grader did. on that same scaled score in the fall. Does anybody have like a question? Or?